So here we have Alex's age is 9 less than twice Paul's age. The sum of their ages is 45. If X represents Paul's age, which equation can be used to find Paul's age? So let's see. First thing I know is that I'm working with two people, right? I'm working with Alex and I'm working with Paul. So I have Alex and I have Paul. The next thing I want to write down, and I want to see these types of notes in your problems when you guys are solving them. So the next thing I want to write down is the other pieces of information that they give me. So first I want to know, what does my variable represent in this equation, which is always going to come from the question. The question here says, if X represents Paul's age, so I know that X is Paul's age, so I'm going to put X for Paul, then which equation can be used to find his age? So now I know that Paul's age is being represented by X in our equation. And now I can go back into the rest of the problem. Wherever I see Paul's age, I can put an X there along with the rest of the information that is given to us. So let's go back to the beginning. It says Alex's age is 9 less than twice Paul's age. So this is important. We know Alex's age is 9 less. 9 less means I'm subtracting 9 from something. And I'm subtracting 9 from twice of Paul's age. Now Paul's age, I don't know what it is, but I know we're going to use X to represent it. And I know Alex's age is 9 less, which means minus 9 from twice of Paul's age, which is 2 times Paul's age. So if I were to write an expression for Alex's age, I know I have to take Paul's age and double it or twice it or multiply it by 2. And then take away 9 from it, right? Alex's age is 9 less than twice of Paul's age. Remember this then, less than twice of Paul's age, tells you to switch the order in which these two things come. So we have 2x minus 9. So we figure out Paul's age is x, which was given to us in the problem. Then we figure out that Alex's age is 2x minus 9 because it's 9 less than twice of Paul's age. And now we have to look for another piece of information to help us out. So if I continue to read, it says the sum of their ages is 45. So that's important. Now sum is a key word for addition. That means we're adding. This means the sum of their ages means I'm adding Alex's age plus Paul's age has to give me a total of 45. And so we can replace these names with with the expressions that we've already found before. Alex's age is 2x minus 9, and I know that if I add Paul's age to it, which is x, that's going to give me 45. And so when I look at the equations that are given to me in this problem, the only one that matches that is answer choice number 3. Notice that I did not choose this to be my answer because this is saying that Alex's age is equal to 45, which is not what the problem tells us. The problem tells us that the sum of their ages, meaning Alex's age plus Paul's age, is equal to 45. So this cannot be the answer. Okay, your answer has to include both of the ages of both of those people. Another strategy that you can use here is you can give the variable that is given to you your own value, see how it works in the sense of the word problem in real life, and then check if that number also works for the equation that you've chosen as well. So what do I mean by all that? So I know X represents Paul's age. So I'm going to say Paul is 20 years old. I'm going to take that X away. I'm going to say Paul is 20 years old. I could have said 15. I could have said whatever age I wanted to. I'm just picking a number for X. I'm picking a value for X that I want to try and see if Paul was 20. Well, then how old does Alex have to be? Well, if Paul is 20, Alex is 9 less, so minus 9, then twice his age. So 2 times 20 minus 9. And that's going to give me a total of 31. Now the sum, if this were true, the sum of their ages would actually be 51, right? So I'm going to check to see if I were to plug in 20 for the equation that I chose, does it work as well? If I do 20 plus 2 times 20 minus 9, does it give me the same thing? And it does give me 51 as well. So I know that the equation that I chose was correct. All I did was pick a random number for the variable that was given to me, see how it would work in the sense of this problem, and check if I plug it into the equation that I chose, if it actually worked as well. So in this lesson, you have two things you can do. You can just write the expressions and equations based on the information given to you, but I want to see notes and I want to see how you're breaking down these problems. Or you can give the variable a value, see how it would work in the sense of the problem, and check which equation would give you the same thing as well. So in this case, when I chose 20, it gave me a total of 51, and when I plugged in 20 into the equation that I already knew was correct, it gave me 51 as well. If I were to plug it into the other three, it would have given me something completely different.